So 2.7. So we've kind of touched this a little bit, but not really. We've seen a couple problems, and that's about it. So basically what we're looking at is what happens if we get way out there. Okay, or way out there. So if we look at something like this, the sketch. Just straight out of your book. I would put it on your paper if I were you, but that's. What are these dotted lines called? Are you sure? Why not? Because I said, are you sure?
Yeah, so I know it's not right.
Can we cross asymptotes? No. Then how's it an asymptote?
It's on, it's there.
They are asymptotes. These are horizontal asymptotes. Yeah. So we have told you that here's the definition for pre-calc. We get close to asymptotes, but we never touch them, right?
Have the basis and change the rule.
Do we get close to them and never touch them as we go to infinity? Yes. So we're not violating the definition, we just didn't give you the whole picture. Okay? So these are horizontal asymptotes. Okay. Limits at infinity define horizontal asymptotes. Let's call this F. So if you get a limit as x approaches infinity, and you get a number, that's the horizontal asymptote. So what is this one? 2, right?
Yes.
Okay, so the horizontal asymptote is y equals. It's the relationship there. Okay. Those will match up. Here's the limit. X approaches negative infinity. It's -1, right? So the horizontal asymptote is what? What?
-2. -1.
The number's right. You're not saying the whole expression.
Y equals really numbers.
It's a line, so you have to say it as an equation. Okay. If you're asked to find the horizontal asymptote, calculate the limit at infinity. Okay. The limit is x approaches infinity or negative infinity. That's the limit you use to show a horizontal asymptote exists. Okay. How do you calculate a vertical asymptote? What makes this vertical asymptote?
What's the slope of the line?
One.
Fine, so the denominator is
Zero.
0. So if you want to have a vertical asymptote, we have a denominator equal to 0. Right, so if I gave you this, there's a vertical asymptote at x. Now this can get a little bit more complicated, obviously. But if you set the bottom equal to 0, solve for x. After you factor it out.
The vertical asymptote back to be there.
The denominator. Let's look at. Okay, what do you think?
Oh. Wait, that's.
Why is it 0?
Because they'll never use the denominator.
Okay, you know the graph, right? The rational function graph. This one looks like this. Okay, so as we head to infinity, we get close to 0. It's a graphical solution. Now, the problem is we can't see very far into the future with that, so it might not be correct. Rationally, logically, you're thinking that number in the bottom is really big, right? So like 1 over 50 billion. Is that pretty close to 0?
Yeah.
And what's 1 over 100 billion? Is it closer to 0?
No.
Yeah, so this number gets really big means the answer gets really small towards 0. That's what we're heading. So denominator is really big. You need to write that down. No answer.
Oh.
So if you got the large denominator, it's going to 0. What's the large numerator going to give us? Plug it in, plug it in. You can say it. Yeah. Big top, the numbers just get bigger and bigger and bigger, right? Where they're headed, off into space, into the infinite. Okay. So this is the general theme of the day. Big bottom goes to 0, big top goes to infinity.
Why is it different?
That makes sense. All right, let's do a couple of problems we can see. Look at them. If you see that, it means you need to look at both of them, positive and negative. Yeah.
And you can split it up into the limit of x over the positive infinity is.
Yeah, you can do two different ones. Okay, here's the nice thing about limits of infinity. All you have to consider are the highest exponents.
Oh, I didn't even see that side.
That's all we're gonna worry about. If you ever want to be messy on your math work, this is a good spot.
You can do that right here?
Yeah, we have the highest exponents, top and bottom, right?
Oh my God. Class meeting now, because that's what
It's in your
it
book, it's example 1 or 2. Okay, you're perfectly good. These are not so algebraic, they're more logical, you gotta think through them. Okay. Top, so we're gonna just do the infinite, the positive, okay? 20x squared, 3x to the fifth. Can I simplify that?
Yeah.
To 20 over 3x cubed? What's the answer? The denominator is going to get really big, right? Yeah, you're just kind of like, well, these numbers are inconsequential because they're really small compared to these big ones. Right, so these ones we just get rid of because they're going to be inconsequential. We're thinking logically now. Then we can bring this down here and simplify it. Knowing that the bottom will grow faster, we know that it's going to get 0. The bottom gets big. Basically, yeah. It's the same. This problem gives us the same answer for negative infinity as well.
It's 0.
It's 0.
Oh.
What are the horizontal asymptotes? Y equals 0. Left, that way and that way.
You don't have to change anything.
You're good.
What if they are different? So what our answer is?
Your answer is 0 for both of them. Well, yeah, basically. So you get to this problem here, you're at the point now where you can just say, whoa, the bottom has the biggest exponent, 0. The top has the biggest exponent, it's going to be a number. Well, I'll show you how to figure that out. So let's look at one of those. Yeah. So we have 3x to the 7/2 plus 7x to the negative 1/2, x squared minus x to the 1/2. And made that really ugly just so you can see the point here. Yep. You guys have a copy in?
Yeah.
Remember about cross and stuff out.
Oh, hold on. Wait, is that just negative or is it negative?
Yeah. Okay. What up, son? Yeah, that's what I'm talking about. Now, what does this simplify to? So, the answer is? Good.
So it is three. Got it.
Because this is 4 over 2, right? Put in fraction form, 7 minus 4 is 3. We can subtract the exponents. What you need to know is that the bigger exponent is on the top, it's going to go to infinity. Right?
All their answers 0 or infinity,
No.
so that you can do the real numbers.
That's gonna be really easy.
Yeah.
Okay.
Now I'm going to show you one.
Okay. Sweet. That was another
Okay, what about this one? Same concept. I'm just going to show you how to deal with the square root.
Alright.
Well, the top is x, right? So, and the bottom. So it acts like, this is something you'll probably hear, like this. Right? This is how it behaves. It acts like it. We're just thinking logically here, not quite formal mathematical. What's the square root of 16x squared? 4x. So we have 12x over 4x, right? Which is? So that's when you have exponents that match is when you get a number out of it. Because they just eliminate each other. They both go over really big, so basically you're not going to get one. Okay.
I like this.
And again, you're going to see like this. What's bigger, the top or the bottom? Bottom's the top bigger. The top's bigger, right? Done.
Thank you.
Oh,
What are the instructions gonna be like when it's, will it just say?
calculate the limits. Calculate the limits of infinity. Calculate. This is pure arithmetic, basically.
So, it's either going to be a number, infinity, or zero.
Is 0 over there? Say that again.
It can be everything. Zero, infinity, or just like numbers, or what would that be?
For any limit? Let's take a look at Know that do you think that's true? What about this? These are odd exponent, right? Negative times a negative times a negative. Okay, what if I had some squared there?
No.
This is x squared, that has to be positive infinity. So pay attention to your exponents. Okay? Sometimes it makes you switch to side. Right. Yeah.
When it's out and down, we have to figure out which thing we use, or when I say, use this method to
You have,
solve problem.
you have to, it'll just say calculate. And you have to know plug charge, algebra, graphical, numerical, limits to infinity. Squeeze zero. And then that sign, let me get here. Well, and sometimes you say calculate horizontal axis because you have to know to do the limit of infinity and how to solve it. That reminded me one of those on your test. By the way, you have a test Tuesday.
I thought it was vacation tomorrow.
We have one more section tomorrow. Friday is a review day. Tuesday test.
Literally, by the way.
I think we're good. Let me get you working. Chit chatting here. Lots of review here. I'll just give you this. This spiral. So I took out half the spiral. Yeah, preliminaries 1 and 2, exercises 7, 9, 12, 17, and 23. And then 2.248 19. About 5 minutes. So if you get a number, what if you ask for like in the bottom right where it says equals or like. So vertical asymptote, you're approaching infinity, the next one is infinity and y goes to infinity, you're actually across and y. So.